What is up, physicists? It is me, Dino, your guide to kinetic theory. And we will be reviewing the solutions to the questions that were given on Google Classroom. And yeah, uh, so just, all right, there we go. Okay, so the first question is asking, what is the average translational kinetic energy of a nitrogen molecule at STP, standard temperature and pressure? And let's take a look at the solution. So as we learned in the video, K is equal to 3/2 times the thermal conductivity times temperature. And if we substitute the values into the equation, we get 5.65 times 10 to the negative 21 joules. Now I had to look up the thermal conductivity and I ended up getting that. So yeah, it might be in your reference tables as well. All right. Moving on. The next problem asks, what is the total translational kinetic energy of 1 mole of N molecules at 25 degrees Celsius? Oh, N2, sorry. Okay. So, we know that the kinetic energy of the total is equal to the number of molecules times the average kinetic energy of each molecule. Now, if we break it down right, we know that there's 6.02 times 10 to the 23 molecules per mole, and Ke, as seen in our reference table, 3/2 times the thermal conductivity, which is 1.38 times 10 to the negative 23 joules per Kelvin, times the temperature, which is 298 Kelvin, and we get that by having the STP temperature, 273 plus 25, which we get from 25 Celsius. And then once you plug it into your calculator, you get 3,700 joules. Alrighty. Next question. Calculate the RMS speed of helium atoms near the surface of the sun at a temperature of about 6,000 Kelvin. So our solution for that is going to be VRMS is equal to the square root of 3kT/m, and we learned this in the video. It's not in your reference table, so it's good to know for the exam, right, just in case. We substitute the values, and M stands for, hold on, give me a sec. Yeah, M stands for the molar mass of the gas in kilograms per mole. So, hold on. It's so hard to read. So, you just plug in what that is. I also had to look it up. And I got 116 meters per second. Excuse me. Now on the AP exam, I know that you can round it if you'd like, but I just chose to keep it at its actual form. Okay. Next question. A gas is at 20 degrees Celsius. To what temperature must it be raised to triple the RMS speed of its molecules? Okay, so we're going to use the same equation. VRMS is equal to the square root of 3kT/m, and we know that we're tripling the velocity, so we have to triple it on both sides, right? We have 3v RMS is equal to 3 times the square root of 3kt over m. And if we're going to find out the temperature, right, we have to scoot that 3 under the radical. So in order to do that, we have to square 3, and that shows us that the temperature must be multiplied by 9. So T, the final T is going to be 9 times the standard temperature, plus 20 for 20 Celsius, right? And that's going to give us 2,637 Kelvin. And you can choose to convert it into Celsius or just keep it at Kelvin. I converted it into Celsius just to keep continuity, and I got 2,364 degrees Celsius. Okay, so now we're gonna move on to the multiple choice questions. Hold on a moment as I try to put this. Okay, so there we go. Yeah, on the document it started with 23, but it doesn't really matter the orders of the questions and all of that. So let's go into question 19. Excuse me, my voice is dying. Okay. A sample of an ideal gas in a tank is in a tank of excuse me. A sample of an ideal gas is in a tank of constant volume. The sample absorbs heat energy so that its temperature changes from 30 Kelvin to 60. What is wrong with me? Wait. Give me a second. Okay. All right. I'm back. I had a drink of water. Hopefully I don't mess up now. A sample of an ideal gas is in a tank of constant volume. The sample absorbs heat energy so that its temperature changes from 300 Kelvin to 600 Kelvin. If V1 is the average speed of the gas molecules before the absorption of heat, and V2 is their average speed after the absorption of heat, what is the ratio V2 over V1? So, we know that VRMS is equal to the square root of 3RT over M. Give me a second, my dad is calling me. Okay, so where was I? VRMS is equal to the square root of 3RT over M, and this means that V is proportional to the square root of T. So that means if T doubles, V will increase by a factor of square root of 2. So in that case, we get C, which is square root 2. Next question. Which of the following will occur if the average speed of the gas molecules in a closed rigid container is increased? And so if we, so usually it would cause an increase in volume, but we know that this is a closed rigid container. And if we look at the gas at a molecular level, you will see the molecules are bouncing on the walls of the container, bouncing against each other, and they're going to start moving like more rapidly and more violently. So these collisions are going to be causing an increase in pressure, which is C. Okay. 57. A mole of ideal gas at STP is heated in an insulated constant volume container until the average velocity of its molecules are doubled. Its pressure would therefore increase by what factor? Okay. So, the equation that I wrote down there is the equipartition theorem. And so it's important to know that N, F, and K are all constants. And basically what this equation just tells us is that K is proportional to T, right? And K is also proportional to V squared, and we get that from K is equal to 1/2 mv squared. So if velocity is being doubled, that means the temperature is being quadrupled if we look at that proportion. And from the ideal gas law, if the temperature is quadrupled, pressure will also be quadrupled because temperature and pressure are both related. What is it? Directly related. Yes. So that leaves us the answer as D. D as in Dino. Okay, that is it for this review. I hope you guys are all doing well. I'm sorry if you heard any snores in the background. My mom is back from the front lines. She's a nurse, so I let her rest in this video. So that is all. Stay healthy, you guys. And yeah. Bye-bye.